So we're just beginning our expressions and equations unit. Today in class we did order of operations. We're going to finish up that activity tomorrow. That's pretty much review from elementary school, but it's pretty foundational to everything that we do, that you have to know what order to do things in. Today what we're going to be talking about is moving towards the algebra side of it, which is what we really focus on. And that's, for today, is translating words into mathematical expressions. This should be reviewed too, but it is getting more towards what we want to be doing in 7th grade. And it'll just keep getting a little more complicated from this, but we're going to build from this point. So what we're going to do today is just give you some keywords. You've probably seen these before. You've probably done something like this before, but these keywords sheet will give you something to look back at anytime that you need to know what to do with a word problem. And eventually, you look back enough, you do it enough, you'll have them memorized. A lot of them you probably already have memorized. So the way we're going to do this is we're going to use a tree map. And a tree map always has a title. So at the top, I'm going to put math key words. All right. And so from here, we're going to branch off into our different areas. I'm not going to do this whole thing for you. You're going to pretty much fill it in on your own. But we're going to go to 5 different areas. We're going to go to the 4 operations: addition, subtraction, multiplication, division. And then there are also a lot of keywords that imply an equal sign. So 5 different areas. You're going to have, let me just show you before you start this, because I don't want you to run out of room. These are the keywords that you're copying down to your own notes. So you can see there are quite a few. So you need quite a bit of room on your paper. So when you're making this chart, just think about the amount of space that you will need. And if you have to go to the back and continue on the back, that's fine as well. But it'll be easier if it's all on one side. So just consider that. So 1, 2, 3, 4, 5. So here we'll put add. Here we'll put subtract. Should be a D there. Multiply. Divide. And then equals. So add, like that. Subtraction. Although we're going to use an X less than labs, I'm just putting the X there for now. Division and equals. So underneath this, we'll put all the keywords. So just let me get you started. I'm not going to go through them because you're capable of it. If further in the year, I'd just probably tell you to do a Google search. There's so many things out there. But for today, what I did for you was I linked to it on my webpage. So if you look here, right now you're in the homework section. If you look at Unit 2 Classroom Resources, that's this area. Click Math Keywords. They're right here. And so I know it's a lot, and this is no fun at all to copy this, but it is important. And if you have it copied, you're going to have an easier time with it. So what you're going to do is one line put sum, then the next one put plus. And if it were me, what I would even do is I would look, all right, what does it look like that's the most important, or what is the least familiar? Like maybe you haven't heard both as an addition. Maybe I would put that at the top instead, so that when you look, that's the first thing you saw. So you don't have to be in this order. It may be a good idea to put them in an order that makes more sense to you. But basically what you're going to do is use this chart to create, let me find my image there, to create your tree map. So when this is filled in, you're going to have something in every category, and then you're going to have a few words for equals. Let me just talk about equals for a second. One thing that means equals, and you're going to copy it from the chart as well, means equals. Anytime in a problem it says this is, that would be an equal sign. And with that, this is more of a grammar thing. If you think of the other tenses, this is from the verb to be. If you think of the other tenses, like the past tense is was, well, that would also mean equals. Any tense of this verb. So when you look at this chart here, and I don't know how good you are with verb tenses because I don't teach language arts to you, but is, are, was, will be, any tense of that verb actually would mean equals as well. So pause the video, fill in your tree diagram, restart it, and we're going to go through a few problems together. All right, so you should have paused the video, you should have filled in the tree diagram, and now we're going to sort of look at some of these problems together. So this should be complete by now. All I want you to do, please do not try to copy these down to your paper. That would take way too long. There's no reason to do that. What I want you to do is just write down the answer that we put. And all that does is show that you paid attention to the examples as I went through them. And this shouldn't take too long. I'm just, once again, if you don't understand, just rewind it and you can see it again. Or type questions into Edmodo or bring them to class. All right, employers in the United States allocated in fewer vacation days than the 25 days given by the average Japanese employee. Write an algebraic expression to show the number of vacation days. So let's start off with our N. And you see fewer, and I don't know, let me click over to this again. Let's see, is fewer on there? Less than, it kind of means the same thing. Fewer is not, but fewer and less sort of mean the same thing. So when you see fewer than, the one thing that didn't come through in the chart, and one of the reasons I wanted to go ahead and do this is, normally you write things in the order they come. So I do N minus 25. But anytime you see the word than, as a matter of fact, go back to your chart, which I've already thrown away. Let me pull it back out. Go back to your chart and make a note, maybe underneath subtraction, because that's usually where you see it. Than means to flip the problem. Make a note on your chart somewhere. It doesn't matter where. This is what than means, and it's so important. So in the case of this problem here, because it says than, you're going to actually put the n at the end and something minus n, fewer than. So it'd be 25 minus n would be the algebraic expression. Hopefully the other ones will match up a little better. So that would be number one. So put number one somewhere, write that down just so that I can see that you paid attention. All right, number two. There are 112 members in the Somerset marching band. They will march in R equal rows. Write an algebraic expression for the number of band members in each row. I would guess that each is one of the words on here. Yep, it is. It's under the division column. It should be under the division column in your sheet. And usually that's what each means. We'll take the 112 rows divided by the number of people, and that would be the number in each row, 112 divided by R. Number three. A cup of cottage cheese has 26 grams of protein. Write an algebraic expression for the amount of protein in S cups of cottage cheese. So 26 grams in each cup. So if you have this many cups, how many? This is one of those where your understanding is more important. I don't see a keyword, but most of you understand, well, if I have 26 and I have that S times, it would be 26 times S. 26S. Number four. Every morning, Sasha exercises 20 minutes. She exercises K minutes every evening. Next week, she will double her exercise time at night. Write an algebraic expression to show how long Sasha will exercise each day next week. So this is a little tougher. Let's look at it all together. So she does 20 minutes in the morning, K every evening. So the first thing I need to know is how much is she doing each day this week? Well, it doesn't have the word, but the word is implied. We need to know how much altogether. If we do the 20 and the K, how much is that if we put it all together? Most of you probably knew that before we did any of this, but let's see if it's here all together. If you're, like, sometimes the words aren't there, but they're implied, and that's the case here. So I know at some point I need to add 20 plus K. And I got to do that before anything else, so I put parentheses around it, because I know I need to add those together, and that gives me each day. Now it says we need to double that. So we're taking this and we're doubling all of it. So most of you should know, once again, what double means, but let's see if it's here. It actually is doubled, is multiplication. Specifically, it means multiplied by 2. So that would be the expression. So a little more complicated, but that's it. You use parentheses when you want to do when we want to make sure we want to add before we multiply. If you didn't use the parentheses, you know the order of operations would dictate that you'd have to do that, and then you're doubling the 20. You need to double all this, not just the 20, so you use parentheses. That usually confuses people, but we'll practice it. We're going to hold up at 4. I do want to show you one other thing from the table that you copied that probably threw some of you. Notice pers here and here. That's not going to make sense right now if I try to explain it to you, but we'll work on it and you'll see it in different problems. It can be either multiplication or division, depending on what the problem is asking for. And we'll look at different examples of when to multiply and when to divide. Most of you can just inductively know by now which of those two things to do when you see the word per. But if you're just strictly looking back, it could mean either. So just be careful with that. And if you get a problem like that and don't get it, just ask for help from someone, and someone will help you figure it out.